In this video, I'll be introducing the concept of an equilibrium constant. In general, you can think about an equilibrium constant as how favorable are the products. You could sort of just think about the equilibrium constant as the concentration of the products over the concentration of the reactants. So, if you have a large K, then that means that compared to the concentration of the reactants, the concentration of the products would be much larger and products would be favored. On the other hand, if you have a small K, then reactants will be favored. Let's start with an example. Let's suppose we had some arbitrary reaction where reactants A and B go to C and D, and this reaction is reversible, so the reverse reaction C and D would create A and B. Now we call the equilibrium constant of a reaction usually by the lowercase k, and how we do it is we relate the concentrations of the reactants and the concentrations of products by taking the concentration of the products and multiplying them together, dividing by the concentrations of the reactants. Now let's look at a different example. In this case, we have 2 of A plus 1 of B makes 3 of D. Equilibrium constants take into account the coefficients in front of the balance equations of the reaction, and it takes it into account in this manner. So we always have the concentrations of the products in the numerator, and if we have a 3 in front, we raise this concentration to the third power, and we divide by the concentrations of the reactants, A, which is raised to the second power, and B, which is raised to the first power, because you could think of B as having a coefficient of 1. So one good question is to ask why the equilibrium constant takes into account the coefficients in front of the compounds. And you can sort of think of it like this. If you have a higher coefficient here, then that means that each mole of this reaction will create 3 moles of the compound D, and so the compound D would increase by a factor of 3 for each time this reaction proceeds. Equilibrium is a measure of the ratios of the concentrations, so if one concentration increases at a much more rapid rate, then we have to take that into account.